All right. Hello and good evening, everybody. This is Toshi Komatsu from the De Anza College Planetarium, bringing you our live virtual star party for December 2020. We'd like to thank the De Anza, or the Foothill De Anza Foundation for sponsoring our captioning, which is going on. So we'd like to thank that. But I'm here virtually with the planetarium, and we've got our friend Mike Askins, who's with his telescope, and we're going to be taking a view at the of the moon and a few other things in the sky. But right now, what we're getting ready for, hopefully, is a view of the International Space Station. So we're going to start off with that, with a little more detail about the things that we have lined up for you in just a little bit. But if you haven't already gone outside, make sure that you're nice and warm, because it's pretty chilly out there tonight, but make sure that you're nice and warm. But you want to go ahead and go outside and see if you can spot the International Space Station if you've got clear skies. I know it's a little bit dicey depending on exactly where you are, but you'll want to be looking towards the southwest. And let me go ahead and turn towards Stellarium here to give a view of the sort of the sky that we're hope that we can get. Right now, I'm focused in on the International Space Station, which is still just a little bit below the horizon. It'll be coming up in a bit, but you'll want to be looking towards the southwest, and it should be coming up momentarily here towards the southwest. So hopefully you have a clear view. If you don't have a clear view of the directly of the southwest, that's okay, because the space station is going to start off low in the southwest before it brightens up, and then it's going to go clear across the sky, making its way almost directly overhead. It'll be a nice bright pass of the space station, so hopefully we'll get a chance to see it. If you miss it tonight because of the weather, there's another one coming up in a couple of days, but won't be as bright or as good as this one that we're hoping to see tonight here. So hopefully it's getting a little bit darker. And Mike, how are the conditions right around where you are?
Well, Toshi, let's see. I'm on my driveway here with the telescope and the camera, and I'm afraid there is a bit of light clouds overhead. And I can't tell you whether or not we can see the International Space Station yet. Um, has it actually gotten above the horizon yet, Toshi, or are we still waiting for that?
It's just starting to come up now. If you're looking at the stellarium view that I have here, there's a little bit of a glow here that glows for the indicator that I have centered on the space station in a minute. Technically, the pass doesn't begin until 5:33 or 5:32 and 42 seconds Pacific Standard Time. So it's just about to clear the horizon. Won't start to actually be visible until it's about 10 degrees above the horizon, which is about 1 fist length or 1 fist width above the horizon. But it'll appear pretty bright. It appears much brighter in stellarium here. But we'll go ahead and see if we can follow the planet or the space station as it starts to come up here. If you're looking towards the southwest, or you're not sure which way is southwest, nearby there's a couple of bright points there. Those are going to be planets. Those are Jupiter and Saturn, and we'll see more of them in just a little bit. But the space station, according to Stellarium, has just cleared the horizon, but you may
Well,
not
Toshi,
quite be able to see it yet.
Toshi, right now I do see Jupiter and Saturn there. And
Okay.
there is a bit of cloud, a light cloud. So I don't think that's bothering me for the ISS yet, but it's making it difficult for me to see Saturn actually.
All right. Well, at the moment, if you sort of make a line from Saturn to Jupiter and you go towards the horizon there, that's where you will want to be looking to spot the space station. But as it gets higher in the sky, it's actually going to get even brighter. It's going to hit a maximum altitude as seen from Cupertino of 85 degrees above the horizon. So again, it's going to pass directly overhead. And again, it'll get brighter as it gets higher. So if you don't see it at the moment, um, you should be able to see it soon, assuming you have clear skies. It'll look like a little spot, but it'll be moving distinctly, and it'll be moving in a different direction from any airplanes that might be going by. But those of you that are watching on YouTube, if you happen to see it, you can maybe put it in the chat. Let us know if you can see it, if it happens to be clear where you are. But passes of the ISS, they happen every now and then. The International Space Station actually does orbit Earth every 90 minutes or so. But you don't always get to see the bright passes because it depends on exactly how the solar panels are oriented. And sometimes that happens in the
There it
middle of the
is.
day, or it's not quite dark yet. But you
No,
can see it, Mike?
no, Toshi. Actually,
Oh,
so I've got a high horizon where I put the telescope, but that looks like we're having a debate on whether or not we're seeing it. I think I see lights flashing on it, so that's not going to be the International Space Station. That's a local plane. So
yeah,
I don't think I see it yet.
yeah, it'll look like a single dot, but it'll look like again a fairly bright dot that's drifting in the sky. So it'll have a star-like appearance. It may not twinkle like the stars, so maybe more like a planet-like appearance.
And
But
Toshi,
again,
I
yes.
I believe that it actually will be going pretty much straight up, won't it?
Yeah, so at the moment it's moving upwards from the southwest, moving straight up. There's a bright star, which you may not be able to see yet because I know it's still getting dark in the sky at the moment, but there's a bright star called Altair, which is a part of the summer triangle. But as it happens tonight, the space station is going to make a very close pass to Altair. So if you see a bright star a little bit higher up there, that's where you will want to be looking. At the moment, the space station is about 30 degrees above the horizon. So if you've got a
Oh, it
clear view
is.
to the
Okay,
southwest,
Toshi, I
30
think I
degrees
do.
up.
I think I do see it, Toshi.
Okay, so yeah,
Like you said, it's about 30 degrees. That's about right.
yeah.
It's about
And again,
half, maybe a little further. It's moving quite quickly now.
yeah, if you do see it, it should appear to move quite quickly,
My
getting
my
close to
problem was
Altair
that
at the moment.
it was. Oh yes, I see what you're saying. Yeah, okay. So it's pretty high in the sky at the moment. I was looking in slightly. I was looking a little more south than west, but
Okay.
I see it now. It is very clear and extremely bright.
Yeah, so it's going to hit a magnitude of minus 3.8, and right now it's passing right by that bright star Altair.
There it
There's
goes.
another landmark for you there. But the way magnitudes work, the way astronomers measure brightness is with something called a magnitude scale. And as it happens, the smaller the number, the brighter things are. So a thing that's a magnitude 2 is not as bright as a thing that's magnitude 1. And those magnitude numbers can go negative as well. So again, we're looking at a maximum magnitude brightness tonight of minus 3.8. So that's pretty bright. That's going to be brighter than Jupiter or Saturn in the sky.
So
Looks like we're approaching the zenith now.
if you're in the Bay Area, yeah, it's directly overhead, Toshi.
Yeah, so it looks like Stellarium just switched around. So it's
It's
yeah,
at
so it
the
should be
zenith.
passing the zenith, and that's about when it should be brightest. So now it'll start to be getting a little bit dimmer, but it's going to make its way right over to the northeastern hemisphere. So it started in the southwest, and it's heading towards the northeast. So it's making a pass almost across the entire sky. My view in Stellarium shows that it's approaching the constellation of Cassiopeia, which is a W shape of stars here. So maybe you can see that in your sky, providing you have clear enough skies, and starting to head down towards the horizon.
That's very bright.
Um, but this entire pass is taking a little over 6 minutes in total to see. So they don't always last this long. They don't always go clear across the sky. Sometimes you only see it for part of the sky there, but you can see it. The whole thing's supposed to be over at precisely 5:39 in 12 seconds, Pacific Daylight or Pacific Standard Time. So we're coming up around that time now, so it should be just about ending. It may have disappeared from view. Stellarium can still show it to me, even if it's twinkled out of existence, at least to the naked eye
It's
here.
still quite clear, Toshi. It's
Okay.
still very bright. It's just got by going by a fairly faint star there. Might be a
Yep.
bright star actually, because I've got a
Um,
little bit of haze.
okay. And then as it gets lower, it's going to eventually fade out and disappear when it gets to be about 12 degrees above the horizon. So again, that's a little bit more than the width of your fist held out at arm's length. So a nice bright pass of the International Space Station tonight. Hopefully you got to enjoy that. I'm inside, obviously, so I'm not seeing it just through Stellarium. But there was a bright pass, a decently bright pass last night that I happened to catch, and it's pretty neat if you can see it. One thing that I can do is I can share with you just a quick little slide image here. If you're interested in finding more passes of the International Space Station, you can go to a website called heavens-above.com. Heavens-above, make sure you have that dash in there, heavens-above.com, and you can put in your particular city or your location there. You don't have to have a login. You can just, there's a little option there to click your location, and you can set your location. And then there is an option under the satellites here for the ISS. This shows bright passes that are coming up here. And you can see that this is what we saw tonight, November 21st, minus 3.8. There's another one later on tonight at 7:13, but that won't be nearly as bright, only a minus 0.8. Still bright, but not nearly as bright as the one we saw. And then the next pretty bright one that I'll be looking for will be on the 23rd. That starts at 5:37, almost around the same time. But that'll be starting off in the west and then make its way across the sky. It won't get nearly as high. It'll only make it 30 degrees above the horizon before it sets again in the northwest there. So this will be a different pass, but you can see them every now and then. And you can check the internet. There's also several apps that you can get for your phone or tablet that'll show you where that will give you alerts. You can look up a chart that looks like this, and then use a lot of them. They'll have a little option so that you can either set a reminder or set a calendar event, so you can go out and find the next time the ISS is making a bright pass near you. And
Well,
looks like
Toshi,
a
I'm seeing I've got Jupiter, Saturn, the Moon, and I'm just checking to make sure I've got everything. What were you thinking of looking at next, Toshi?
Well, we can go to the moon, but we do have a question in the chat about how many astronauts are in the ISS. And I
Good
forget right off the
question.
top of my head, but there was a mission, the first official crewed mission sent on a Dragon capsule to the ISS that launched a week ago. And they arrived at the space station earlier this week, Sunday night, Monday morning. Something like that. So that brought a crew of, I believe, 6, and there are already a couple of astronauts on the station as well. So there's probably about 8 or 9 or so at the moment. But that was an exciting milestone because it was the first official changing of crews using the Dragon capsule. But yeah, so the
cool.
ISS still going strong with more astronauts making their way here. So, but Mike, I'm going to go ahead and turn it over to you so that we can take a look at the moon here. I know you've got your telescope focused in on the moon, so I'm going to go ahead and switch over to your view, and you can get it back in focus. But I know you were saying earlier that it's going to be a little bit hazy, and that's because there's again a little bit of haze where you are. That's one of the unfortunate things about astronomy. We're always contending with the weather and hoping for clear weather. It's decent enough tonight, but why don't you go ahead and looks like you've got us nice and centered on a beautiful crater there. And why don't you go ahead and take it from here? Yeah.
Okay. Well, yeah, I've got my little telescope here. It's a little bit bigger than between a 4 and a 5-inch objective. And I've got my phone mounted to it. So what you're seeing there is the image through the eyepiece, the way you would see it if you were here looking through the telescope yourself. Of course, I put an adapter, and I put a phone, and then my phone in the adapter. And so what you're looking at is the very southern part of the moon. By the way, in case you didn't know, tonight is first quarter moon. Astronomers have some interesting names or different phases of the moon. There's, of course, new moon and full moon, which I'm sure everybody's heard of. This one is sort of a half moon tonight. If you're out there braving the cold at the moment, you can probably you could probably see that it looks like just sort of a half. But because of the geometry of what's going on with the orbit, astronomers call this a quarter moon, a quarter. It's because we're actually seeing a quarter of, of the entire surface of the moon tonight, half of the side that's always aimed toward us. And so you always get the very best views of things on the moon when they're right on the edge between the lit part and the dark part. That line that goes between the lit part and the dark part, astronomers call the terminator. The terminator. And if you look carefully there, and the phone is constantly trying to improve the focus, and so that's why it's going out of focus and coming back. And we do have those thin clouds sort of drifting over it, which is sort of why things are constantly changing there. But if you look at that crater that's in the middle there, that was the one that Toshi was referring to. It's called Maurolycus. Maurolycus is about 70 miles across from one side, from the dark side, the edge of the crater on one side to the edge of the crater on the other. It's about 70 miles. Now in the middle, if you look carefully, and I'm going to try and center Maurolycus a little better here, so that, because it seems to be drifting up just a bit here. There we go.
Yeah, and while you're doing that, Mike, I will note that we can actually see in the telescope some of the clouds drifting by. And sometimes we get people who say, "Well, you've got a telescope, even though it's cloudy. Can't we still look at things?" And if you use a telescope on the clouds, you just get a closer view of the cloud. So if it's completely clouded over, your telescope doesn't let you see through the clouds. But luckily, you've just got a thin layer.
Yeah, it's looking pretty good at the moment, Toshi. If you look very carefully, you can probably also, I'll see if I can zoom in just a little bit more here. And look carefully at the image itself, and hopefully you're able to see that it's shimmering. It looks like it's sort of underwater, and that's the same effect. It's the motion of the Earth's atmosphere. As we go through the day, the Earth's atmosphere heats up. As it gets dark now, as it is, it cools off, and the thermals in the atmosphere move around and make the light coming through it sort of dance around the way it is. And you can, hopefully the zoom is not distorting it too much, but if you've got good network reception tonight, you may be able to see it just sort of shimmering. And that's one of the primary reasons why astronomers always try to put telescopes on places other than Earth's surface. It's because we have the atmosphere, which of course, I know Toshi and I are both very happy that we do have an atmosphere, but it does make it more difficult for us to see the objects that we look at up in the sky as clearly as we could. So that's one of the reasons why we spend lots and lots of time and resources here on Earth to try and move our telescopes out into orbit, because we don't have to contend with the atmosphere. Anyway, if you look at Maurolycus, that big crater that's in the middle, and I do need to try bringing it down a little bit more here so we can continue to see it. Look at, in the middle of that crater, there are some little mounds. Well, I told you that the whole crater is about 70 miles across. So those aren't really little mounds. They are tens of miles across. But those are what astronomers refer to as central peaks. And because of the physics of the way that a meteor strikes the moon's surface when these craters are made, there can be some interesting things that happen to the physics of what's underneath. And one of those things is the central peak. And as we continue to look at some other craters, you'll notice that many craters, but especially the ones that are bigger, show those central peaks. The central peak has to do with sort of what they sometimes call, what I've been reading about, slosh back of, as you can imagine, when a crater like this is made, a meteoroid is hitting the surface of the moon extremely hard and extremely energetically. And what happens is several different things. Um, the 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 moon material underneath is pushed to the side, and also the energy with which the meteor hits actually melts some of the rock. It can when it's a big enough impact. So due to the motion of the material just by hitting, and also having to do with this impact melt, which is the energy turning um, the soil there or the lunar surface into liquid for a period of time, um, makes those central peaks sort of possible. Um, so the other thing I'd have you notice is look at how many partial craters are around it, and maybe you can think about how you would tell which ones are older and which ones are more recent. And the way that astronomers do it is you can see that there are several craters there that look like you can see all of pretty much all of them. There hasn't been anything else happening to the surface of the moon right in the same spot as Maurolycus to sort of destroy parts of it. Um, I can also see another smaller moon that's, I got to be careful here, or a smaller part of the moon, a smaller crater. Um, anyway, you have to just think of it, especially near the poles. What happens is there's a lot of meteoric material that hits there, and there's just a whole slew of craters there that are just kind of right on top of each other. You'll see that that's not the case for all the portions on the moon. Um, Toshi, I was thinking of moving up the Terminator a little bit. Did you want to mention anything about where we are at the moment, though, before I do that?
No, just again, some areas on the moon are more crater than others. We're looking at a beautiful area that if you have your own telescope, that's something that you can look for. As you're moving along there, Mike, I'll just kind of note that oftentimes we like to look at the moon, not when it's a full moon, because then the moon becomes very, very bright and can actually kind of hurt your eyes, not like in a damaging way, but it kind of hurts to look at the moon when it's fully bright. So we like to look during the shadowed times, and you get more detail when you're looking along the shadow, the terminator that Mike was talking about. And that's because that's when the crater walls and any mountains can cast their shadows, and it gives the moon a real three-dimensional look to it. When you're looking at a place that's fully illuminated, it can just look very flat, and you can tell where the craters are, but they just kind of look like circles there. But when you have the shadows there, it gives a real depth to those craters, and you can tell some craters are deeper than others or shallower than others. So first quarter is a popular time to be looking at the moon, and full moon not so much.
Well, what I've done is move from Maurolycus to a crater that's just above called Goodacre. And Goodacre has an interesting crater that hit after Goodacre was formed. There's the focus, a little bit better now. You can see a smaller crater is sort of impinging upon it. And unfortunately, I can't show you, but if you look at that one Goodacre, which I would guess is probably about 50 miles across, there's one that's a good 25 miles across that you can also see above it that looks like it came later. Toshi, are you seeing the ones that I'm talking about?
Yeah, we can see them.
Okay. And let's just continue up the Terminator here a little bit and take a look at some of the other craters and some other central peaks as well. As I move up a little bit here. Now, by the way, I came up with 2 crater names so far. I feel like I'm very proud of myself that I was able to remember those. All right, so I do have a couple of notes here, but am not going to be able to name all the craters. So I guess maybe you're a little disappointed in me, Toshi. Sorry about that. But as we continue to go here, we'll see if we can find some larger craters. Maybe I'll be able to tell you about those. In fact, I see something already at the moment that's off to the side there, and I'm going to see if I can bring it over in front of us. It's a very famous threesome of craters. I'm going to try and put it right in the middle there. There we go. And the one that has the beautiful central peak, when it gets focused again there, is called Theophilus. Now, all of these were named. I mean, what's so nice about the moon is it's got so many features that everybody who's ever been associated with doing anything interesting about any of the sciences or mathematics or philosophy or anything like that seems to have some name associated or seems to have their own crater. Let's see if we can get that to refocus there.
Yeah, while you're refocusing, I'll just note that I did look up how many astronauts are on the ISS right now. So right now there are 7 astronauts on the station. It's crew number 64, but 7 astronauts, one of which is a Japanese astronaut. There's a couple of Russian astronauts as well. So again, it speaks to the international nature of the space station, where we have several partners. I think there's something like 16 international partners that contributed to the construction and development of the space station. So it's a really it's a modern marvel, both for technically and also just the fact that it shows that countries can really cooperate and work together.
Well, thanks, Toshi. The one with the central peak there, Theophilus, is on top of, so it came later than the one that's underneath it there, and that one's called Cyrillus. And the other one that's a little bit farther away from the other two is called Katerina. And those 3, let's see if I can recall the sizes of those. Those are about 60 miles across, each of those. So let's keep moving a little bit here. See if I can get back to the Terminator a bit. There we
And
go.
you can see it looking at that trio as you move along, that the definition around the trio, again, it looks kind of flat, not quite as interesting as Mike approaches the Terminator again, where you can see some of those deep shadows and shadows within the craters there. You can hopefully get a sense of what I was talking about earlier with giving the view there some real depth with those shadows. And every time you look at the moon under different lighting conditions, those shadows, they do change. So the moon can really have a dynamic look to it.
Gee, Toshi, I love that view now. We're seeing some lighter portions, the dark, deep shadows, and you can see some of the surfaces are extremely flat. And we should talk about that a little bit, Toshi. Maybe I can show you if I move out a little bit here. You may be able to see this great big flat plain. That's called the Sea of Tranquility. Now they're called seas, these big dark areas, because people originally imagined that they might be big bodies of water. Of course, we don't, even though the stories or the official story about water on the moon changes periodically, we've never, NASA's never told us that there are huge bodies of liquid water. We wouldn't expect that because of the conditions. There's no atmosphere, and the water we'd expect at the top would boil away. But that's the, let's see if I can see close enough here. You're right now, the point where Apollo 11 first landed is in the field of view there. And unfortunately, because of the layer of clouds that we have here, I'm not able to see the craters that I use normally to spot that. But I would say it's very close to right in the middle. Now I know that lots of people say when I'm showing people the moon through the telescope, they'll say, "Can we see where the astronauts landed?" And the answer unequivocally is no, not just through the telescope. You have to get telescopes that are closer, like say that are orbiting the moon itself. And in those cases, you can actually start to see some sign of those early 70s landings on the moon. They can even show the lunar excursion module, the descent portion. So you can see it, but I'm just telling you that you're seeing it somewhere in there near the middle.
And I can add sort of my view. What I'm looking at here is a map, and we'll tell you a little bit later on where to get this map. But that the Apollo 11 site is right here. So we're sharing the view. We're looking at both my map and your view, Mike. And near the center of your view, what we're seeing are there's two small craters next to two larger craters, and they sort of kind of arc around to get you towards where Apollo 11 is. So I would say that you're pretty close to on the mark there, that this is the site of the Apollo 11 landing, right near those craters. So I think you're right on the mark there. But again, unable to see it in your telescope. I don't know if that means we need to get you a more powerful telescope, but it would have to be quite the telescope indeed to be able to resolve from Earth the Apollo landing site.
Now, Toshi, you showed us Apollo 11, but I also see on your map there another Apollo, right?
Yeah, so Apollo 16 a little bit further away, but that was the landing site for the Apollo 16 mission. I'm going to zoom out here. You can see a little bit higher, sort of near the boundary between the Sea of Tranquility and the Sea of Serenity is where the Apollo 17 landing was. And a little bit further up along the Terminator is where the Apollo 15 landing was. So again, there were 6 spots where we landed on the moon during the Apollo days. And those are often popular targets for people looking at the moon as well.
Well, Toshi, you spoke of it before, but there's something called the Mare Serenitatis, the Sea of Serenity. And that's what we're looking at right in the center, or you can see how big it is. There are some mountain ranges at the edges of the crater. Remember how these seas formed, and I didn't mention it, but I'll elaborate here for just a moment. These originally were huge meteoric impacts that carved out huge parts of the surface of the moon. And then later lava flows smoothed out the basins. And actually I can actually see enough detail here, even with the clouds, so that we can see a little crater that's in the middle of the Sea of Serenity there. And that one I happen to know the name of. It's called Bessel. And Bessel is a little tiny crater right in the middle of that huge walled plain.
And you were talking earlier about how which craters are older or versus younger. So part of the idea of that is that the newer craters are going to form on top of older craters, right? So if you have a crater inside of another crater, the one that's inside is obviously going to be the one that formed later. And it's similar with the mare, these ancient lava flows. They filled in areas and they covered up any older craters. So any craters that you see in the mare, like that little one that you were just pointing out, it should make sense that formed after those lava flows covered them up. So that's a newer crater than when the lava flow happened. And that's one of the ways that astronomers date things on the moon as well as on Mars. Any place with a solid surface, you can kind of date things by looking at the craters and studying which craters are on top of other craters or other features that you know that may have covered up previous craters.
Well, while we're taking a look at this sea here, if you look over on sort of the far side of the away from the Terminator, there's another big crater that's over there that is only partial. And I'm hoping people can see that. It's much larger than that little crater that's right there in the middle. That's called Posidonius. And I think it's from the root Poseidon, who of course was the god of the ocean. So that kind of makes sense. We're looking at the ocean here. And Toshi, it was just pointed out to me that there was a question in the chat that was about what filters I'm using here on the telescope. And it turns out that there aren't any filters. We're not using any filters at all. What I would say is the most filtering thing at the moment are those silly clouds, which look like it's possible that those are going to clear up here in a bit. It looks like it's getting a little bit better. But anyway, no filters in the telescope specifically, but you may see little bits of uh, cloud action sort of drifting by there, and that's very possible. But it is true that you can sometimes use filters to make certain types of features look more, um, pull out more interesting features by using filters, but not in this case. And look, I can see that little one Bessel a little bit better now. Let me go ahead and continue up the terminator here and see if we can go right up to the northern part.
Yeah, and speaking of filters, as you reposition yourself, Mike, sometimes when people are looking at the moon with a telescope, they'll use what's called a neutral density filter, and that doesn't change the color of anything, but it just helps limit the brightness from when you're looking at something really bright like the moon through a telescope. It can again sort of kind of hurt your eye. It's like having a bright flashlight. If you're looking at the bright moon, it's almost like having a bright flashlight shining directly in your eye. It can appear quite bright. So sometimes you put a neutral density filter just to limit some of that light. But sometimes people will use color filters when you're looking at nebulae or planets to bring out a certain detail, things like that. But now, Mike, you just have the natural filter of those pesky clouds.
That's right. So let's see, I've got a couple of craters that are in the middle there. One of them, the littler one, is called Eudoxus. Eudoxus. And that one is something like 15 miles across, something like that. The other one was named in honor of Aristotle, the great Greek philosopher. And that one is called Aristoteles. And Aristoteles, let me look at my notes here, about 25 miles across, something like that. Now, what you can't see in the dark part, there, the other side of the terminator, is a huge, it's the biggest one on the moon. It's the biggest mare on the moon. It's called Mare Imbrium. The Imbrium event, when it occurred, made the biggest one of these huge mare basins. This is the biggest one on the moon. I can't show you at the moment because it's over there. You'll just have to imagine it, because the line between night and day is sort of between Eudoxus and Aristoteles and that huge Mare Imbrium. Let's see here. We're getting right to the northern part there. What's interesting about the northern part of the terminator here is that several of the craters were named after explorers of the North Pole. Let's see if I can remember some of those names here. There's one called Bird at the very top. And what other ones do we have there? Well, there's several. Barrow, Meton, Chalice. I thought I remembered one other. I can't see it at the moment. Anyway, let's see if I can get up a little bit higher there.
And the poles, again, they tend to be quite interesting to look at because, again, you get more shadows and several craters that are up there. The idea is that some of those craters at the very top or at the poles, whether it's the North Pole or the South Pole, that some of those craters may be deep enough that if there's any water ice at the bottom of those craters, that they may never see any sunlight. So you may get preserved material, preserved water that stays at the poles at the bottom of these craters. And for those that are thinking about colonies on the moon or setting up moon bases, having a water source is a concern. And so one place that they're looking is, again, at the poles where perhaps they can access some of that ice that never hits any sunlight, or the sunlight never hits that ice. And therefore, you have some ancient ice there that you can use.
All right, well, thanks, Toshi. There are lots and lots more craters and Maria that I could show you, but we could be here all night, and I would sort of freeze to death because I am getting kind of cold. Hope,
We
thank you for
could.
anybody who's been brave enough to stay out and take keep looking at the sky there. Looks like the clouds are starting to go away, Toshi. How do you figure?
Yeah. Well, how do the planets look, Jupiter and Saturn in particular?
Well, I can see both Jupiter and Saturn over there. Would you like me to try and point the telescope at maybe Jupiter?
Yeah,
I
why don't
could
you
do
go ahead
that.
and do that? Well, I'll switch back over to Stellarium, and we
Okay.
can kind of take a look. We've been looking at the moon here. I'm back up in my view here. Um, and the moon is pretty much due south here at the moment. And panning over to the west of the moon or to the right of the moon, again, we see those two planets, Jupiter and Saturn. And Mike, which one are you going to focus your scope on, just so that I know which one to focus on here?
Jupiter is the first one, Toshi, and then maybe Saturn after that.
All right, so we're looking at, we're focused in a little bit closer to Jupiter. That would be this one right over here. Now it's sort of down into the right of Saturn there. Again, we're looking, if I back up here, looking towards the southwest and how close those two planets are. We'll talk more about that in just a little bit. But here's a bit of a preview of what we hope to see through Mike's scope. Won't be as good because, again, the camera isn't going to be able to compensate for the difference in contrast as well as the human eye. But if you had a nice clear view looking through a scope, then it might look a little something like this, where I've turned on the labels, where you've got Jupiter, and then you've got the four Galilean moons here. You can see Ganymede and Io, and Europa is actually eclipsing Jupiter at the moment, and then you have Callisto on the far side. Further away. So if I take away those labels just so that we can see what it looks like, you have these two moons on one side of Jupiter, one moon on the other side, and again, Europa is is passing in front. So what I can do that Mike, well, we won't be able to see through Mike's telescope because of the contrast. If we zoom way into Jupiter, then you can see
Oh
this
boy.
black dot on Jupiter. And that's not because something bad happened to Jupiter. That is actually a shadow of Europa, which you can see. Let me zoom in a little bit more here. Um, Europa, again, right now is right in front of Jupiter, and the sunlight is coming in from sort of the lower right in our view. And so that's casting a shadow onto Jupiter. So it's actually making a little eclipse that if you could stand or maybe float on this particular spot on Jupiter, you would see the moon here partially eclipsing the sun, maybe totally eclipsing the sun. Um, Gets to be the sun. Europa's actually about the same size as our moon, but it's much further away than we are to the sun. But that means that the sun is going to look smaller as well. The Great Red Spot is also visible. It's almost right in the center of Jupiter at this moment. And that's a popular target for looking through binoculars here.
Well,
Um,
Toshi, I actually looks to me like I've got Jupiter in the field of view. So if you want to spotlight that, I'll see if I can show that to you.
all right, so let's go ahead and we'll focus in. And looks like so because Mike's looking through his telescope, it's a mirror image from what we're looking at Stellarium. But we can see there Jupiter and then two planets on one side and one planet on the other side of Jupiter, making a nice little line of those three moons there. Again, that fourth Galilean moon right in front of Jupiter. Um, and if you wait until if you wait another 10 minutes or so, Europa will actually emerge from being in front of Jupiter. Um, but as we saw with Stellarium, and see Mike's zoomed in a bit here again. Two moons on one side, one moon on the other side there. Jupiter, again, pretty washed out in the view, but if you could put your eye to the eyepiece, you'd be able to see a little bit more detail, maybe even some of the
Toshi,
banding on Jupiter.
I think you said that Europa was uh, in in front, so it's going across the surface or
Yep.
the cloud tops.
Yeah, it's going across the disk of Jupiter, and that will go on till about 6:22 Pacific time. So another less than 10 minutes, and then it'll move away from Jupiter. And if that
So
shadow
Toshi,
there, the shadow will be there until 8:30 actually tonight.
okay, but we will be able to see it come out from the to see it finish its transit, right? So, and that would be on the side where there's only one moon at the moment, right?
Correct. So in your view, it would
Okay.
be on the upper left there. So.
Okay,
Um,
let's see if I can get this a little better in view here. Oops.
But again, if you do happen to have your own telescope, Jupiter and Saturn are something to definitely keep an eye on for the next month, certainly, because the two planets are getting closer to each other, closer and closer to each other. Um, and in fact, on the 21st of December, so exactly 1 month from now, Jupiter and Saturn are going to appear so close in the sky that they'll only be 6 arc minutes apart. That's 1/10 of a degree apart in the sky, which in theory you should be able to see with the naked eye. Maybe a little bit tricky because they'll be really close, but you may still be able to resolve them as two separate objects. But they'll look really, really close. And what's unusual is that we'll be able to see them in the same field of view looking through a telescope. Now, the two planets, Jupiter and Saturn, they haven't gotten this close together in 400 years. The last time they got this close together in the sky was in the year 1623. So that was quite a long time ago. They'll do it again and get this close in the year 2080, but that's still quite a ways away from now. So that's still another 60 years from now. It's better than waiting 400 years. But you get a close pass of these planets every now and then. They catch up to each other, but sometimes when they have the really close passes, sometimes it happens when they're near the sun as well. So we just don't get to see it. So the last time they got close was about 10 years ago. They made a close pass, but it wasn't nearly as close as we're going to see this year. So do take a look at them coming up.
All right. Well, maybe we can go back to it in a little bit, Toshi, and see if we can actually see that moon Europa come out from in front of Jupiter.
Yeah.
But
So maybe
the other,
maybe what I can do is I can go back to Stellarium here, and we can zoom out. And what I can do is do some time travel here and take a look and see where the planets are at the moment, and skip ahead into the future to see where they'll be in just a little bit. So
oh,
again, right
cool.
now we've got Jupiter and Saturn in the southwestern skies as the sun sets. I'll go ahead and bring up the my date and time calendar here so that we can see that. So again, we're at November 21st. If we skip ahead about a week into the future, you can see Saturn here has gotten distinctly closer to Jupiter there. And in another week on the 5th of December, it gets even closer still. And a week later on the 12th, they get closer, and on the 19th in Stellarium, they look like they're just a single dot. There actually is some separation. Let me go ahead and skip ahead right to the 21st. Again, Stellarium is showing them as a single dot, but if I zoom in on them, then we'll be able to see that there is actually just a little bit of separation. Again, in the real sky, they won't be quite as bright as this, so they won't get washed out. But again, you can see a bit of separation between them. Saturn's going to be to the right of Jupiter, a little bit fainter there in the sky, and may have a little bit of a different color. In fact, maybe if you're still outside taking a look at Saturn, you may note that it has a bit more of a yellowish golden color to it than Jupiter. It's certainly not quite as bright as Jupiter, but has a little bit of a yellow color to it. So that's something that you can take a look for. But as we get again closer and closer and closer, you see those moons, those Galilean moons going around Jupiter there. But let me back out again to sort of a naked eye view. If we were to skip again into the future, looking on the 21st, and take a look through a telescope here um, at Jupiter and Saturn through a telescope like Mike has. This is a simulated view of the sort of view that you would get with Jupiter in the center here, Galilean moons here, and Saturn right next door to the two planets. So having two planets in the same field of view through an eyepiece is a pretty rare thing. And certainly to have them this close together, just a tenth of a degree apart, that'll be something definitely worth checking out. The only
Well,
problem, of
Toshi,
course, yeah.
I'm sorry. I was just wondering if you know whether or not with a pair of binoculars we'll be able to tell the separation.
Yeah, you should be able to see it through binoculars.
Hmm.
Again, theoretically, it's possible to see it with just with the naked eye. But depending
Oh,
on your particular eyes, it may be a little bit tricky because again, a tenth of a degree is pretty close. Um, but in theory, you may be able to see it. But binoculars will certainly help, and a telescope will be even better. But as I was saying, the only problem for us in the Bay Area, at least in the northern hemisphere, is that at sunset, these two planets, again, we're looking at the December 21st here. These planets are going to be very low in the sky. Right around sunset, they'll again only be about 10 degrees above the horizon, so they'll be pretty low. And you don't want to wait too late. You can see here already by 6:30, they're this low in the sky, and the two planets, because they're right next to each other, they end up setting. Uh, we'll put the we'll say they're setting right around there, and that looks like that's right about 7 p.m. So 7 p.m. standard local time, they've already set. Sun is setting about 5 o'clock, so you only have a couple of hours really to take a look, and they'll be pretty low in the sky. But if you can do it on the 21st, again, that's the closest these planets have gotten appearing together in the sky for the last 400 years. So definitely something for the record books.
well, Toshi, I'm wondering if we could take while we're waiting for Europa to come out from in front of Jupiter there, so we can actually see that fourth Galilean moon. I'm wondering if there's any questions that I know that I'm not seeing some of the chat. Maybe you are able to see some of it, or perhaps Gracie. But maybe we could answer some questions because there's only a few minutes before that's supposed to happen.
I did see a few people in the chat noting that they saw the space station, so that's exciting that people were able to see it.
Oh,
Um,
good.
I know one thing that I can share with people is the moon map. If you like that moon map that I was looking at to reference where the craters on the sky, just a quick slide here. You can get a moon map from the Goddard Space Flight Center. The Scientific Visualization Studio here, and I put the URL here, svs.gsfc.nasa.gov/4768. Why 4768? I'm not sure, but that's what the URL is. But you can get a moon phase and libration that takes you to this page here. They make a new one every year, so you can just do a search for moon phase and Scientific Visualization Studio. That'll bring it to you, but you can put in any date and any time. That's in UT hours. So during standard time, you have to add 8 hours, and during daylight saving time, you add 7 hours to get the UT hour. But you can put in any date and any hour of the entire year, and it'll generate a map for you. You click on this, the thumbnail here, and that'll generate this full map that you can see here that has some information that's here. And then again, a very nice labeled with all the craters there that you can check out, has the Apollo landing sites marked as well. But depending on which day you pick, it'll change this map. So if you pick a day that's more of a crescent moon, it will show using Lunar Reconnaissance Orbiter data, which is a mission from NASA. If you're looking at a crescent moon, it'll show the crescent or the shadow of the moon exactly at the date and time that you choose here. Again, this is tonight's map that we've been using for 6 p.m. local time for us in the Pacific time zone. But if you put in a different date, different time, it'll show you how the craters are shadowed. along the terminator, show you exactly where the terminator is. So you can check that out for yourself. Again, I'll sort of go back here. I'll leave this up for just a little bit here.
And
SVS dot.
what's so
Yep.
cool about that website is that all that image that you get is reconstructed for you from lunar reconnaissance orbiter photographs. The lunar reconnaissance orbiter has been up there since about 2010, photographing the moon, just lots and lots of photographs. And what they do is, it is very difficult to tell exactly what the moon is going to look like from night to night, because the gravitational fields between Earth, moon, and sun are so complex. But this thing figures out exactly what the moon is going to look like for a given hour that you're looking, or even better than that. So I use it a lot for shows like this, where we're trying to understand what's going on exactly the night that we're looking. And so that's what I like about this particular one, is it's really very close to seeing just what you'd be seeing in the real sky.
Yeah, exactly right. And if you're wondering what libration means there, it's because, as Mike was saying, there's a lot of gravitational interaction. So there's a little bit of a wobble to the moon as we're looking at it. So we don't always see exactly the same face of the moon here. For example, this sort of Maria that you can see right on the edge, depending on the exact time and date that you're looking, we might see a little bit more that's on the edge, or a little bit less on the edge there. Because as the moon, as we're seeing it, it kind of wobbles around. So we see a little bit more, a little bit less around the edges, depending on exactly the time that you're looking here. So that's why this map that it generates, it shows you exactly what you can see at the time here. So you can see a little bit of, again, this libration sort of map here, showing the orientation and how it's moving around. So again, it gives you a really, really accurate prediction or a model of what you're going to see on that particular date and particular time that you chose here.
What do you think, Toshi? You want to go back and see if Europa is peeking out yet?
Yeah, let's take a look at that, and we'll probably have to end here. But I've spotlighted you again here, Mike. So maybe we can see if we can see it maybe a little bit washed out because of the contrast.
Hang on, we'll see what we can do, Toshi.
But in theory, Europa has now um, cleared Jupiter. But again, it may be lost in the glare.
It's only 5 minutes after you said 6:22. I think it's 6:27 or something like that.
Yeah. Yeah, even looking at Stellarium, let me go ahead and add my Stellarium view here. You can see that in Stellarium Europa, it's still right on the edge. Technically, if you measure it, you'd probably find that it's cleared Jupiter, but again, it's sort of right on the edge. Very difficult to resolve here.
Well,
So yeah,
Toshi,
so it's right at the edge there.
how about if we, to sort of wrap things up here, we're very close to Saturn and it's still visible from the telescope. Want to go to Saturn real quick? And I know that with the issue that you were talking about in terms of the contrast, we can't really see it as but we can see that it's elongated because of the rings. And it's right close by. And I can just actually go there pretty quickly if that's okay.
Yeah, so why don't I'll go ahead and remove your spotlight for the moment here, and I'll sort of zoom out in Stellarium and give a preview. I'll set up a preview for Saturn, which is again right next door. It's the bright thing right next door to Jupiter there. And I'll go ahead and zoom in. It's a good time to be looking at Saturn because the rings are nice and open towards us. Sometimes when we look at Saturn, the rings are a little bit more edge on, so they just look like a couple of things sticking out from the side there. But we see a few moons around Saturn as well. The largest of the moons is a moon called Titan. It's actually the second largest moon in the entire solar system. But Saturn now officially has over 60 moons, 60. So there's a lot of moons that orbit, but most of them fairly small. But Titan, again, one of the larger ones, and one of the only moons in the solar system that actually has a substantial atmosphere to it. So there was a probe, a European probe, that dropped down into the atmosphere, and so we've got one photograph from the surface of Titan, where it's actually the conditions are such that we think it's similar to what the early Earth might have been like before life arose. So we think that the conditions on Titan may be conducive for the development of life, except instead of a water cycle, it's so cold there that methane, which appears as a gas here on Earth at normal temperatures, it appears as a liquid on Titan. So it actually rains methane and ethane on Titan, but it acts like water on Titan there.
All right, Toshi, why don't we go ahead and if you just spotlight me, we'll see if I can spot it real quick here. We're pretty much out of time.
All right. Well, you are
Let's see
spotlighted.
here. Okay, hang on just a second. I may need to zoom in a bit.
Yeah, it's looking blank at the moment.
Okay, hang on. Come back. There it is. Oops, a little bit too far. Let me get it in the middle.
Yeah, we can
And
see
now,
it again, a little bit elongated there. And that would be due to the rings. I think if I look closely enough, I can convince myself that there's a little bit of spacing in part of the with the um, around the planet there.
well, your imagination is better than mine, Toshi.
Well, having a good imagination is part of being an astronomer looking through a telescope.
There you go. All right. Did any other questions show up in the chat? I think we're over by a couple of minutes. We need to be done.
Not that I can see, but we'll go
Okay.
ahead and we'll come back here. So, there is a question. Are there any big cosmic events happening in 2021? I know I
Good
haven't had a
question.
chance to look ahead to the new year with events coming up. Have you had a
Well,
chance to look, Mike?
I've started looking at January, but nothing that I can remember is um, super exciting there. I know that there is a total solar eclipse the end of December, but it's not visible from anywhere close by. The tip of South America is where you can see totality. So Toshi, maybe you can take a vacation down there and check it out.
Yeah, if only. Um, but yeah, we'll definitely be checking out other for events. We'll also be taking a look to do some more of these star parties here. So we want to thank everyone for tuning in here and watching us. So on behalf of Mike and myself and the entire planetarium staff, we'd like to again very much appreciate everyone tuning in. Hope you enjoyed yourselves, learned a little something. Stay tuned to all of our social media. I'm sure we'll put those links in the description, but we'll check out our social media to find out the next time we're going to be doing a star party. We don't have one planned for. Look for us to come back in the new year with some more virtual star party events and other things going on. And Mike is responsible for noting events that we share on our social media. So do check that out. But do check out our website. And once again, thanks for tuning in. Mike, do you have anything to add?
I hope all our planetarium friends have a nice holidays, and we'll see you again when we come back in 2021.
All right. Well, best of the holidays to everybody, whatever you're celebrating in the holiday season coming up, and would like to wish everyone a good end of the year and some good news to show up and some exciting events in 2021. So thanks very much, and have a good rest of your evening, everybody.
Bye bye.